Okay, good. Now we are good to go. We'll start. So, most important point, I'll be presenting using a Jamboard. You see here the whiteboard. So, we'll be just using this for the presentation. And the topic for today is this is called low level design. It's part of a system design, but does anyone has any idea what could be the questions on low level design? Anyone?
So basically, Tarun, can you remind us, can you talk about what kind of technology, tech stack you are going to implement? That schema you are going to design related to database?
Yes, Shivam. But
Yes.
okay,
So,
database
according
design.
to
Yeah, that a database design, that's a good point. Okay, yes, definitely. No, you shared uh, one interesting point. There could be database design, and the other is tech stack, technical stack, right? Choosing the technical stack. This is also part of low level design, but generally there is not
the low
directly
level,
this.
in my
Yeah,
according to me, the low level design is basically like the overall picture of a feature or of a product, how the class diagram, how the classes are interacting to each other, how the relationship of the classes, and what are the what are the functions that particular class will perform, what are the parameters that class will take. So at the low level, I will totally at the low level how my product is look like there are different type of classes. Like if I take example of a student portal, so like the student class, a teacher class, what are the property of a student, what are the property of a teacher, what are the functions they will take. Yeah,
yes,
so these are
yes.
things basically cover the low level design. Yeah.
Correct, correct. Definitely, absolutely right. So, if I want to define low level design, I'll define it like that. Low level design is a design to such a deep level that if it is given to a developer, he can use that low level design document and provide a complete implementation of the application for which he has been given low level design, right? So it has all the details, which is about what technical stack to choose, the entire database design, your class design, and even the implementation or what algorithms to implement, right? Which is generally represented in terms of sequence diagram or activity diagram, or in simple terms it could be flow charts as well. So design which is no very easily convertible to programming language code is the low level design, right? Agree?
Yeah,
Anyone
I agree.
has
But
any other perspective on this?
How the code is modular, I mean, readability, how we can reuse it, I mean, in case if you want to extend it in future.
Absolutely,
Those,
absolutely.
yeah.
Okay, perfect, perfect. Yeah, this is a very nice point you raised, that there are design considerations, as we have design considerations for high level design. For low level design, yes, these things are right, but what I have is specified is only the basic thing. But most important points to remember is, first is it should be readable code, right? So no, basically these are good characteristics, that the design should translate to readable code. Readable means understandable. And why readable, understandable? Because it should be maintainable, right? Next thing is, it should be, as you said, extendable, right? So if you have to add more features to the existing code, you should not rewrite it. So if you have to rewrite the code again in order to extend, then that code is not extendable. Correct? Anything else?
Does this also include exceptions handling as well? So let's say in case of something goes wrong, how that's managed as well? That also is included.
Yes, definitely. It should be very good point. Yes. It should be, I'll say, reliable. Code should be reliable, or code should be robust, right? So that it should be able to handle all kind of error situations, and should be able to provide good information for the users to let them know what problem is being faced. If the system is not working as expected, why it's not working. So it should be reliable, it should have good error handling, and it should be robust. Robust means you could have a working design, but if you give large set of inputs, or if you give number of inputs one after the other, it will not always run forever. At some point of time it will crash. So that's also not good design, right? So these are various points which we have to take into consideration while doing low level design. But coming back to my first question, which was, how are these concepts tested in a system design interview? So first thing is, we should understand that if you are giving an interview in any organization, how will you be asked on these concepts? How they will test your concepts around low level design? Any idea? What could be example questions, example interview questions, which will test your understanding of the concepts learned so far on low level design?
Maybe we need to write a small code and they will review it and see whether it follows proper design pattern, and it can be decoupled. I mean, is it something related to that?
Give specific example of what kind of code could be asked. If you know any example problems, sample questions.
Okay. I never faced any interview, but maybe like
Yeah.
they will ask to write a simple program, a backend program or anything. Once it works, they will just once it input. I mean, it is able to produce a proper output based on the input. They will review it. They will do the kind of code review.
Okay.
And ask questions why you have done like this.
Okay. Sure. So anyone else want to add something more to this?
So, to add to the Mahesh point, they will
Yes.
see whether you are implementing all the basic principle like solid principle. Whenever you define a class or something, they might be looking into it.
Okay. Yes. But what could be the starting questions, right? So assume, I'll give this answer. So I'll give you some examples of questions which will be questions to test low level design, right? So last time we covered tiny URL. That question could also be used to test your low level design skills as well. So in the tiny URL session, we understood that how will we design the system which could be scalable. But the same system could also be used to test your low level design, because in that the interviewer may ask that, okay, how would you design the hashing algorithm, or how would you convert a URL to a tiny URL, provide the code for that, right? So here, we discussed that there should be some hashing algorithm, which could be say SHA-256. So it's just not that you take an input as URL and then you write a function which will be just calling the SHA-256 library, and you will get a or base 64 encoding, and you will get the tiny URL. So this code is not sufficient. Actually, you have to also consider the situation where you have concurrency. So in that case, your code should be thread safe. Okay, and then whatever inputs you are receiving, you have to also store it in the database. So you have to provide this code where you take care of concurrency handling, and then you take care of storing the data in the database, and you can also take care of the atomicity of the database transactions, so that if some failures happens while storing the database, there is some retry mechanism or mechanism by which there is no way where you have inconsistent system or data. Okay, so this is one example. There are other examples as well. There could be questions like design snake and ladder game. So this is more of a low level design question, because when you design any game, games are multiplayer games, but there could be games where you have hundreds of players playing, so there are thousands of players as well. You have to take care of performance, scalability, and at the same time, very important thing is you have to take care of the real-time response. So most important factor in game design is fast responsiveness. And if I give you an example that, okay, it's just a simple game, it's a desktop game where you can play with the computer snake and ladder. If this is the question, this is a low level design question, right? So here things which will be tested. So one more important point here is, when we say the code should be readable, understandable, maintainable, this also can be synonymous to, we say that the code should be object oriented. It should have a good object oriented design. So low level design also tests your understanding of object oriented concepts. But object oriented concepts, I understand that these are the basic concepts and you will already have a good understanding of it, right? So anyone having any doubts on object oriented concepts or object oriented programming, I'll not cover that. I'll go to the next level directly. I'll jump over to the next level ahead of object oriented programming concepts. So any queries or any clarifications anyone has on object oriented design, object oriented concepts? When do you say we have a good object oriented design? For object oriented design, you have to have good understanding of, there are few concepts. One is inheritance. Even before that, there is a concept of abstraction. There is a concept of encapsulation. There is a concept of inheritance, and there is a concept of polymorphism. Okay. So these are object oriented design concepts you should apply. Okay. Even sometimes you can also say data hiding. Okay. Data hiding, abstraction, encapsulation, inheritance, and polymorphism. These are various data these are various object-oriented programming concepts. So you should make use of good object-oriented design. So when I'm saying that, okay, we need to design a snake and ladder game, you should be able to model objects and methods in the snake and ladder game. So for example, there is a board, which is an object, and at the same time, you may have players as object, you may have scores of the player as properties of the object, and you have various functions of an object. Say for example, for player, you have a function which is move or throw dice. So in that case, they throw the dice, and when the objects, they call any methods, they interact with each other. So when there is a throw dice method called on the player object, it will create a new number from the dice object, and dice object may have some random algorithm which will return some number which will be in the range of 1 to 6, and this value is what the player will use to make a move for his whatever you say, the peg. So this is how your design should be. So if you are using object-oriented design, you will identify appropriately different objects and different methods of each of these objects and what properties of objects to be modified. So when a throw dice is there and you get a value which is between 1 to 6, there would be a property of the player object which will be position, and in that position you will add that number, right? Definitely in low level design you need to use data structures and algorithm concepts as well, because what data structure would you use to design the board? That is also very important consideration. So it will automatically test your understanding of data structures and algorithm. So any guesses what data structure to use on board for snake and ladder game?
2D array.
Okay. Any other answers, or everyone agrees with 2D array?
Yeah.
Okay. Okay, hash maps. See, most important thing is your design should also be simple. So use as simplest data structure possible. Correct? So you have a position. Now every position can have a starting place or the destination, right? No, so starting place is the position itself. So if I am at say position 10, and in that 10 position there could be a ladder, so I should also have a representation there that I have to move from that ladder from 10 position to say 31 position, right? So if ladder is from 10 to 31, how would you represent it? So give also some suggestions on what should be the data structure which not only stores the positions, but how will you store snakes and ladders? So one suggestion was...
See, I will use the 2D array for this thing.
Okay, 2D arrays. Okay.
In the 2D array, the first row will be full of, 1 minute, 2D array. Okay. See, 2D array will have two values. The first value is from where the ladder starts, and the second value will be the ladder ends. Like that I will maintain.
Yeah. Okay.
Similar thing I can get for snake also.
Yes. Okay. Got it. Got your design. But now I will ask you to give one more thought, right? See, 2D arrays are used to represent rows and columns. You have two-dimensional data to represent, right? Here you have one dimension only because the numbers are from say 1 to 100, right, in this case. So you can you not do this in single dimensional array, whatever you design you have?
We can do, because instead of having one possibilities, instead of having two array, we can have single array.
Yes.
One array, that is one possibility we can.
Correct. See, rendering could be a different approach. So the simplest design I will say is you have a single dimension array, right? Index could be its position, right? And if the array is having a ladder, you can have some plus numbers or minus numbers, right?
Okay.
So let me try representing this one possibility. There could be multiple designs, but assume I can have some 2D array like this, right, and so on, right? So just I have an array which is from index say 0 and to the last element 99. Correct? So this way I can represent the entire snake ladder board. Yes?
Yeah, got it.
Right? So this is sufficient. So this is one simple design. There could be other designs as well, but just see that this is so simple design, and definitely you can render it in 2x2 graphics in your game, right? Because you can just do it in 10 columns. So you will have the line wrapping and then you can show it in a two-dimensional nice graphics. The numbers but the data is the source of how you will render the board. Correct? So yes, this is one question, how you will design, and also consider simplicity as one of the important factor. Any other points you would like to discuss here? So now I will not skip that part, that how will you identify the classes, objects, methods, properties, because I think that you will know, right? But yes, so this will test your understanding of data structures, and it will also test your understanding of coding. And the interviewer may ask you to code one specific function, right? As I gave you an example that there will be a throw dice method of a player class. He may ask that, okay, how will you decide whether there is a winner? He may ask you any specific method which he may ask you to code. So here you have to also provide the class diagram. So in addition to the data structure, you'll also provide the class diagram. Now, very important thing is that while you provide the class diagram and when you code, you take care of solid principles, right? Anyone knows what is solid principle? This is a very important concept in low level design, which is concept of solid principles. Now, one more thing I wanted to add on the reliability and robustness part. How will you ensure that your code is reliable or robust? How do we know that? Right? a code is reliable or robust only if it do not have any code smells. Agreed? Now what is code smell? Anyone? Indicators of problems in the code are called code smells, right? So there are various examples of code smells. One example is duplicate code. Other example is a very large or I would say complex class, right? Another example is large method, and there are many code smells. These are the problems in the code which will cause your program to be either non-reliable, non-understandable, and hard to maintain, right? So all the best practices, if they are violated, they become code smells. Correct. Any queries on this? Code smell is clear?
Yeah.
Great. So now let's come to solid principles. Solid is a abbreviation. It has various other concepts. There are 5 concepts which you need to understand for understanding the solid principles. Has anyone heard about this earlier? Solid principles.
Yeah, kind of like each class should have some individual responsibility, like kind of we shouldn't mix together, for example, people, and if you have some other class
Yes.
that should solve only, I mean, for example, people class, it should have only relevant information or method about people. It shouldn't
Yes.
mix with the other class.
Right. So yes, it stands for, though so many terms are there. So single responsibility. Then the other one is open closed principle. Then there is Liskov substitution principle, interface segregation, and the last one is dependency inversion. So these are the various principles which are important or which are part of the solid principles, right? Now this principle is all stated by, there is a person called Robert Martin. He has introduced these concepts, right?
Or Uncle Bob.
Yes, he is also known as Uncle Bob, right? So the person, he is Robert C. Martin and is popularly known as Uncle Bob. I would advise you to look into his books, and there are some live sessions from him on YouTube also. So he explains good programming concepts very well, and he talks about a lot of concepts like unit testing and how to do good coding and also agile development as well. So yes, he is one of the thought leaders in low level design. Correct? So let's look into each of these principles, and they are very simple principles. First is single responsibility principle. Single responsibility principle states that your class should have only single responsibility, right? So as I gave example of a snake and ladder game, here we can ensure that we have single responsibility for each and every class we define. So for example, I said we will have a player class, and for Dice, we will have a separate class. And see, if every class they are having single responsibility in this case. Dice has just the function to generate a random number between 1 to 6, and player just has a single responsibility of tracking the position of that particular player, right? Board has one responsibility of rendering the board, and it just takes care of storing where the ladders are, whether the snakes are, right? And what else we have in that? So I think pegs will be on some positions. We can also sometimes replace it with player, because if you have uh, a, you have to track score, if you have to track history of the player, how many matches he has played and how many wins and losses he had, then I will advise have a separate class player, have a separate class peg for tracking the location of that. Because if you are using the same class to do two things, for example, tracking the history of the player and tracking the position of the player in the current game, then this will be complex class. It will become a complex class. It will become hard to understand, hard to maintain, because when you change any code, you can have side effects in other functionality as well, because a class is having multiple functionality. To simplify things, yes, it's very simple principle. It says all classes should have single responsibility, and there should be only one reason to change a particular class. So for example, if I want to generate dice numbers from 1 to 12 instead of 1 to 6, I'll need only change in one class, which is the dice class. So it's both way. So if I'm changing a class, it is for this single reason, and if I have to make changes to a class, then since there is only single responsibility, so there is a single reason for change. This is about single responsibility principle. Second principle is open closed principle. Right? Before I go to open closed principle, is everyone clear with single responsibility principle? Very easy, nothing complex about it. But yes, to apply this in your code, in your design, requires experience. So if you have experience, you will be able to identify that this single responsibility principle, when is it violated and when it is not violated. And in your design, you should always have single responsibility for each and every class. Now next thing is open closed principle. Open closed principle states, anyone wants to take this? What is open closed principle?
It's the class should be open for extension and closed for modification. Yeah. So what are the feature we are making? So whatever we are adding, so we should not alter the existing code, and so that is completely closed, and we can only add the functionalities over that, like adding a new method that can use the existing behavior.
Yes, absolutely right. Absolutely right. So I'll give an example. Say, consider iPhone. iPhone is considered as a classic example of open closed principle. Whatever is inside the iPhone, it's all closed, it's sealed, right? So for example, the processor, the various capabilities like memory, it's all closed. You cannot change the configuration once you purchase it. If you purchase a device which is 64 GB, you can't change it to 128 GB. If you want 128 GB, you take another device. So this is closed, right? So the class is closed for modification, but it is extensible at the same time, because people would be wondering, how can design be both open and closed, right? So what it says, the core functionality should be closed, because that should not be modified, because it will then misbehave, it may misbehave. But on the other hand, it should be extensible as well. In iPhone, once you purchase it, you can install hundreds of apps, and you can do everything, like photo editing or listening to music, Truecaller, and there are so many extensions which you can apply, and you can use it for multiple purpose, from navigation to video recording to playing music. So many functionalities you can add. So this is open closed. It's at the same time also open to extensions, but there is very clear definition that what could be extended, what could be closed, right? So now if I come to the snake and ladder game example, here the core functionality should be closed, which is that how the winner is decided. Whoever goes to the 100th place, he is the winner. The behavior of snakes and ladders, they have to be closed, because that should not be modifiable. But then how many number of players can play, that could be changeable, right? You may have a 2-player game, you can have a 4-player game, or you can have n number of players in a game. So that is extensible. Maybe you can have various themes. Board could have different themes, different kinds of music played when you are eaten by a snake, or you kind of jumps through a ladder. So there could be various animations, various multimedia effects which could be put in. So these are some of the extensions which could be there on this game. So there you will have this open closed principle, that you should define very well, in a well mannered, that what things are closed for modification and what is open for modification. It's very important to have both these things, because extensibility is very important. So you should have extensibility, because iPhones are sold because they are extensible. Earlier, you used to have feature phones, Nokia phones, where you can't add any additional apps. They became out of market because of this lack of extensibility, lack of openness. They were closed, but they were completely closed system. So now even in cars you have tablets, but then there are extension. You can sync your phone and then get more apps for your car tablet as well. Last time we discussed the design of autonomous vehicles. So that also follows open closed design principles, where few things are open and then there are extensions possible, right? So this is about the open closed principle. Now coming to the next few principle, which is Liskov substitution principle. Any idea what is it? What things can you substitute in a code?
So by the definition, it's whenever we are inheriting. So according to the Liskov substitutions, any parent class can be the object of the parent class can be override by we can use the child class.
Yes, definitely.
So
Yes.
it should not something that we cannot hold the functionality of anyone. So that states Liskov substitution.
Right. Absolutely right. Yes. So here the functionality. No, so what it says is you should always program to the interface, right? Because this makes your code more flexible. So if you program to an interface is a base class which has multiple implementations or multiple child classes, then you can replace the base class with any of the child classes, right? This way your code becomes very maintainable and extendable as well. So if you want to add more algorithms, so assume you have a code which does the sorting. You have a base class where you apply some very small or very simple kind of sorting. But if you have the interface, which is the base interface, which is referenced in the code, you can just change the implementation by any of the child implementations, and these child implementations can have more complex sorting algorithm implemented. So you don't need to change your logic at all the places. You just change the object. Since the interface defines the contract for what methods have to be called, signature is there of each and every method. So your code becomes very easily modifiable. You just change the object for the implementation, and your program will use n number of sorting algorithms, right? So this is about the substitution principle. Correct? So anyone has anything to add to that? So in the last, 2 classes back, we studied tiny URL. In tiny URL, there are hundreds of ways with which you can convert a long URL to short URL. If you program to base interface and you can create multiple implementations, you can have user choose what kind of algorithm he may want to use for shortening the URL, and based on some customization at runtime you can decide what kind of implementation you want and what kind of output you would like to generate. So this is the advantage of Liskov substitution principle, that you can substitute child classes, base classes with child classes. So your design should also ensure that you have this principle applied so that you can substitute implementations and can enhance the functionality of your application. Next we have interface segregation. Anyone who would like to take this?
Tarun, I can give an example for this.
Sure.
Let us consider an interface called bird.
Yes.
Okay, we will do common features of birds in that interface, the
Yes.
properties building. But we won't define properties like fly and all in that particular thing. Because, for example, ostrich won't fly.
Yeah.
Raccoon won't fly. So we won't define the property called fly in this common interface.
Yes.
We'll define a separate interface called fly, separate interface called swim, because penguin can swim. That is a separate interface. That is how we will segregate it.
Yes. Right. Great. So absolutely correct. Because see, one important thing is that things which change, they should be separated from things that do not change frequently. Right? So there should be segregation of interfaces, and they should have segregation in such a way that the segregation is based on frequency of changes. Your interface may need to be split based on what needs to be changed and what do not needs to be changed. For example, yes, there is a good example. This is a classic example. It's also mentioned in some books like Head First. So you may have a bird class, you may have a duck class, you may have other classes as well, which is ostrich. Birds, some of the birds can only fly. Some of the birds could fly and swim, and most of the birds will also speak. So you may have different methods. But if you just define one interface, which is say iBird interface, which have all the methods, then no, you have to override the methods. For example, fly methods, when you implement ostrich bird, will also implement the iBird interface, but then you have a fly method also. So what you have to do is, in that case, is you have to override the fly method, and when this method is called, it should return operation not supported. Yes, so that makes your class more complex. But what if you segregate these interface, create another interface which is swimmable, which is flyable, and for birds which are able to swim, you implement swimmable interface. In that case, duck will also implement swimmable as well as flyable interface. Ostrich will not implement any of these interfaces. And then some other birds, for example crow, may implement flyable interface. So here you don't have this problem of having to override some of the methods depending on whether the behavior is supported or not. So makes the code less complex and more maintainable and also understandable as well. Because just by looking into the interfaces which a class implements, you can say whether that bird can fly or not. In the previous case, because there was one generic interface which was iBird interface, you have to look into the implementation and then you'll only get to know whether a bird can fly or not. So this is about interface segregation concept. Clear? So the main idea is have those methods only in the interface which are frequently changing and don't have lot of unrelated methods in a single interface. Depending on your situation, your domain, you would need to segregate the methods accordingly. Now last one, who will take this dependency inversion? What it is? Okay, then I'll tell you. But before that, I'll also explain one more concept, which is tight coupling. Tight coupling is term which is used where if you have a change, it's very difficult to make the change because you have to change at multiple places. So if you have such code, this is called tightly coupled code. There is another term which is called loose coupling. That means there is less dependencies between different components. And loose coupling is preferred because this allows you to make change easily. Now in dependency inversion, this is what you try to achieve. You try to achieve loose coupling, and loose coupling you try to achieve by not, so what actually we do is assume, I'll give an example. We take an example from the last class, which is autonomous vehicle. If you are designing a vehicle and vehicle has various components, so the main vehicle class will be responsible for creating all the subcomponents. If your design is like that, this is tightly coupled system, because your vehicle needs to know what all components it has to create, right? So it has to create a battery, it has to create headlamps, it has to create windshield, it has to create seats, maybe tires, everything. So it has to know a lot of things. What if you do the inversion of dependency, right? How you do inversion of dependency? It's also called inversion of control, IOC. Also it's called sometimes dependency injection. So one way to loose couple this is create a separate factory class. Factory class knows about what all components to create, and your vehicle class only calls the factory class. So this is kind of a dependency inversion where you have separate class to ensure the creation of vehicle. So in the previous case, vehicle class was responsible for creating itself, which looks reasonable, but then it looks intuitive, but it has a problem that it needs to know a lot of things, and it will become complex and it becomes tightly coupled system, because if you have to change any component, you have to change the vehicle class as well. But if you have a separate class which takes care of creation of vehicle, you are having inversion of control or dependency inversion. So this is about dependency inversion, dependency injection, or inversion of control. Spring make use of dependency inversion to a large extent, right? So in Spring you have @inject annotation or wired, it's having wired annotation. What it does means is, here the container is taking care of what is dependent on what part, right? Rather than the code taking care of it. So you can very easily change the dependencies in that particular case. So this is dependency inversion. Actually, it's a large topic. If I go by examples, we can have a separate session on dependency injection, because it's a lot of concept and that has lot of applications. So in Java, this concept, I would say, is having so many implementations and is having practical applications, that it is a very good topic to take. I think an entire session could be taken on this, which is around first what's the context, and then dependency injection, how to do various ways of doing dependency injection and various benefits which it brings. But yes, in a layman term or in a very fundamental manner, this what I explained, that rather than the class being taking responsibility of creating itself and its components, you change that, you invert that responsibility to some other class, right? Generally this is how the programming languages work. You have a constructor is responsible for constructing the object. When you construct an object, you construct subcomponents of the object as well. So in inversion of control or dependency inversion, what you do is you have an additional object which takes care of the creation of another object. So you have a kind of a factory method. But yes, in Spring, for example, this is implemented in the container. So you have a web application server, and web application server takes care of instantiating the object. So as a programmer, you don't need to create new instances of the object. You don't call the constructor of the object. You just put at the rate wired annotation, and container will instantiate. When it will instantiate, when it will remove it, that entire logic is taken care by the container, and programmer need not have to worry, because if you are creating a object, you have to also take care of destruction of the object to free the resources, memory, etc. So in dependency inversion, this responsibility is given to an external entity rather than the entity itself. Right? Clear? Great. So this is most of the topics of low level design. There is one more important topic of low level design, which is design patterns. And design patterns, again, a vast topic. It would need a separate session, and I will believe it may take 3 sessions because there are so many design patterns. Almost like 20 design patterns are there. So to cover them, 5, 6 per class we can cover, and that way 3 sessions may be needed. Also we can kind of classify them as creational, behavioral and structural patterns. So the other topics which we cannot cover today is the design patterns, but what we covered is object oriented design and solid principle, which is almost like 60 to 70% of the low level design concepts. Great. So are these topics clear? Any queries?
Clear.
Perfect. And then I gave you an example of how it will be asked in an interview. So one way it will be asked is you will be given a problem like design tiny URL, and you would be asked to write code for one module. And then you have to take care of not only the data structure selection, algorithm selection, but also selection of how will you handle concurrency, how will you handle database read and write, right, caching in case required. So you'll go through the code, but yes, no one expects here working code. You can create pseudocode also. You don't need to remember all the methods, because you may not be remembering the JDBC methods or Hibernate or any other framework, ORM framework, which you will use to write to the database. And same could be for the case of multi-threading concurrency control as well. But you should be able to explain it through pseudocode, your design, which is the low level design, and it should handle how it will take care of not having any code smells, and how you will implement all these principles. More principles you will implement it in your code, more good your performance will be in the interview. Great. So yeah, if there are no further questions, we can close this call. Great. So then, no. Thank you. Have a
Yeah,
nice
thank you.
day ahead. Enjoy our
Thanks for
Sunday.
the conversation.
Okay.
Thank you.
Hope you learned this and you found this useful. And definitely, I'll share the recording and then see you next week.
Thanks, sir.
Thanks, sir.
Thank you, Tarun.
Okay. Bye.